All right, so in the last session, we were able to model this structure, and I was about to show you the next few steps to complete your structural design. But the first one I will be showing tonight is to check for errors, because sometimes when you do your modeling, you may feel like everything is good until you care to check for errors to see whether you have some axes that are not um, straight enough, some slabs that are overlapping, or some columns that are directly sitting on your slab without support and all of those things. So one thing you want to do is to check for that. Then how do you do that? Um, you go to review. If you're using like my version of ProtaStructure, you'll find it here under review, building model check. So because we want to check our model, then you start. So you discover that on my own model, it is zero. Um number of errors is equals to zero. So I can close this now. The next thing you want to do is also to relabel your members. Why do we need to relabel our members? In case you're having multi-story buildings, and because you inserted columns, for example, you inserted your vertical elements such as column and walls on different levels, and they're supposed to be continuous. For example, the same column, let's say column on grid line A1. Let's pick one column for an example. Let's assume that this column starts from the ground floor. This column now is on the roof. Let's assume that it's from the ground to the floor first, and then for the first to the roof. Now, this column is supposed to have a common name because it's just one column, not three columns. Even though it is column from the ground to the first, and the first to the second, second to the third, and all. As long as it is a continuous column like that, it's supposed to have a common name. So I prefer to make it a common name, such as this. So when I go to relabel the members, you can relabel your column, shear walls, beam, slab, rib, in the sense that if you have one column one, it means the first column on the story one. And when you get to the next column now, you see something like two column one, meaning that same column one on the second story. So when I get to the third story, it is three column one. So it's not that you find one column one on the ground floor and then another, it names two column one, another kind of column on the second floor entirely. So your work is not disorganized. I don't know whether you understand. Do you understand what I'm trying to say?
Yes.
So great. So that's the essence of doing that, so that it makes your work very organized. So then after you do that, sometimes you want to check for unused axes. Maybe you have some axes that you did not use. But for my own, you can see it says all axes in the model are being used by members. So that's good. Sometimes your axis may not be straight, okay? Maybe due to modeling errors. So once you click this, you know. So it says nearly orthogonal axis not detected in the project. So all my axes are all correct. Now that we have checked for all of these things, okay, we can move to the next one, which is analysis. And under analysis, you find building analysis. So once you click the building analysis, um, the first thing you will want to do is to edit materials. And why do you do that? It is in this place that you select what kind of reinforcement you want and what grade of concrete you want, or grade of steel. Okay, so if you're dealing with concrete, what grade of concrete do you want. Is this C16 to 20 or otherwise, or maybe 2025? As you want it, just let us know. Yeah. So C25, C25 30, 28. So yeah, you can manipulate all of those things. Okay. But let's keep it as C16 to 20 for our work here. Now, the rebar diameter for column now, if I want 16 ticked, 20 ticked, 25 ticked, you see that now these are the three I want. When we get to the wall, whatever it is you want, 10, 12, 16, you just select it. You do the same thing for all the ones you want. Like beams now I've selected 10 for links, 16 and 20, 25. Okay. So you do that. For a foundation floor, say rebar diameter 10, 12, 16, 20. And the grade of concrete you can put whatever it is, 16, 20. The links Y10. In fact, let's retain Y10 for links. I don't want I whatever. So you can use OK. Now that you've done that, the next thing you want to do is the loading combination because it's going to design or analyze and design based on certain loading combination or load combination. So you want to check for loading combination. So you generate loading using loading generator. So now on the loading generator, you don't really need to do much except you want to customize load cases. Okay. Now this is create factored G combination load. If you want, that's why I said if you have a customized load you want to do or something different from what has been there as default, that's when you need to do a whole lot of this. Okay. But usually, the only thing I feel is necessary if you are not customizing anything here is if you need a unfactored dead plus life combination, which is basic thing we use. Like we use day in day out. Once you get your dead load, you get your live load. This it shows it to you separately, and then there are combination also is on factored combination. We have factored combination 1.4 GK plus 1.6 QK, and we have 1.0 GK plus 1.0 QK. Though that one is unfactored. So sometimes we want to just click that, and if you don't click it, no big deal. All right. So this is it. You can see this number one is the unfactored. And that's what I called 1.0 plus 1.0, 1.0 GK plus 1.0 QK. That's unfactored. So this is 1.25 G plus 1.5 G MQ. 1.25 G 1 point M 0.00000. You see that? All of those things. So let me just check for one thing. All right. So um now that we're done, you just come here and click OK. Did I press anything now? And press OK. Now, after that, you go to analysis. We've done the building model check earlier. In case you did not do it, then you have opportunity to do it now. So after that, this one, you start with the building analysis. Just click column, beam, we're analyzing, we are selecting bars, then you start to run your building analysis. You have to wait for a while until it completes the process. Until it completes the process. So it's going to inform you when it's done. So with this, I'm going to show you how to achieve a part foundation today, and you're going to do it also yourself. Then the next class will move to the next kind of foundation, which is raft foundation. I'll be showing that too, and then I'll show you pile foundation also. and progressively we're wrapping up, and I'll show you how to export and all of those things. All right, so is the beam reinforcement design is going on now. All right. It says building analysis completed successfully. So we can close. Then we'll now have to go ahead to check the design. What exactly did he design? Let's close this. You find that in the post analysis. So let's check for the column or wall designs. So here you see that all the column actually passed for Y16 all through. No issues about that. We can move on to check for the beam reinforcement. And under the beam reinforcement, we have for all the stories, story one, story two. If you want to check for each story in particular, you can filter axis, filter by story. I want to check the first floor beams alone. So these are the first floor beams. Okay. If you want to edit, say, a beam, for example, you once you click on double click on the beam to check what reinforcement is there, and you can do to fit what you want. Okay. All right. So and also filter to check the next story and see. So all these passed. Great. So we do not have any issues on that. Now to the foundation, the one we wanted to today. Story 00. We want to put in pad foundation. By the time you highlight all, now some may do it one after another, which is quite a lot of time for you to. What if you have about 100 columns to support? It will take your time. So just highlight all like this. Right click, then you see insert pad put in. Okay, so once you click insert pad put in, it brings you a pop-up box. All right. This is because this is 20 an advanced version of product structure. If it was maybe 2018 or so, the box would not be as big as this. It shows you a little dialogue where you see the bearing capacity and all of those things. Now, this one that is showing you this. You asked that we didn't put a bearing pressure, we didn't put all our parameters, and then we are here already. So if you want to do that, go to foundation settings. Once you click foundation settings, you go to general. Now, under general, you can see soil unit weight. Usually we don't change this. Don't change that. Allowable soil automation factor, you can leave it at this. The stress of the soil, this is what I'm talking about. Allowable stress of the soil. This will be in your soil report. So if you're using 200, 150, 125, 100 as specified in your soil investigation report. All right, so you can do that here. So this is where we do it. Then you can also check for the minimum steel bar spacing. That is in the design of in the software design, the spacing between bars. All right, you don't want it to be more than 250. Never should it be above 250. Some will keep it lesser than that even. All right, so you can do that here. And all of this steps, this size increment step is how much gap, when you're trying to increase the sizes, like in steps. If you for example, if it was 150, the next increment you would have would be 250. from that, just like that. The depth increment. Like what this one is the size of your pad, of your foundation. That's what I'm saying. Of your pad or your whatever foundation it is. So if, for example, you design 1 meter by 1 meter and you're trying to increase 1 meter. So the next thing is going to go to is 1.1, 1.2, 1.3, 1.4. That's what it means by this size increment. So the depth also, the depth, maybe 450, it moves to 550, it moves to 650. That's exactly what it means. All right. And this concrete cover, we all know what cover is. So 40 mm. So those are the real basic things here on the general. Now we're not dealing with pile, so I'll skip this till we get to pile. So I just do okay. Now that we have done that, we can design all. Now, the depth, did we choose a maximum depth for that? Maximum part base depth. Minimum is, why would I put minimum 400? That's a bad choice. Let's put minimum to be two 250. All right. Minimum footing width. Let me put 900. All right. So do we have maximum? We don't have maximum. All right, let me leave it at this. Okay. So let's design all. So you see it loading on this right bottom corner. So the depth is way quite much. I wouldn't know why this is that quite much. Let me see what's going on in there. Now, right, once we right click this, so you see that the depth is 450. Let's try to make it less. You can see that it's reducing by 100 steps that we've already selected. Now it's only accepting 450. Why so? So let's check what's responsible for that. Now the load is not even quite serious. It's 204.3. Okay. Soil stress 280. Okay. Reinforcement. All right. Okay. Okay. 450. That's quite a lot. Okay. Let's see. There's a way you would do it. Let's increase the ly and lx. Let's see 1 2 by 1 2. It should have effect on the depth. Let's see. Let's try 1.3. 3. Now you can see if you want to use 350, you have to go as far as 1.5 by 1.5. All right. Or 1.6 by 1.6, but it doesn't make sense anymore. So once your part for this kind of structure is going this high, the dimensions doesn't make too much sense. All right. So let's keep it at 1.2 by 1.2. I like that. Or 1 meter by 1 meter. I think it passed at 1 meter by 1 meter. All right, so that's good. So now let's assume that you have, okay, we have similar columns, similar part that are the same dimension, the same dimension. So for example, let me design selected again. So that, for example, this one 600, the next one 600, 600, 600. Do we have another one? Yes, they are the same size. All right. We can group them. Once you have selected this guy, just come here, group selected. It becomes the same. You have grouped them into the same category. Okay. So you can do that for, sorry, I did I, okay. You can do that for 500 too. 500, 500, 500, 500. All right, and then group selected. You do that for 400 also. Then group selected. Now you see that you now have five column and pad types. So in case you want to do the detailing and then the export, it becomes easy for you to put together into your drawing instead of having about 20 different kind of pad bases. Okay. So you press OK. So this is what we have. So clicking on this, the group shows. Clicking on this, the group shows. Clicking on this, the group shows. So this is what we have right here. So this is exactly the through and through for pad footing. Okay. And I would have loved to take it out into AutoCAD. Okay, but I will do the export lessons together after I've taught you all the foundation types. All right. So what I'd like you to do is you'll get you produce this to this point. All that we have done today, produce to this point. And I'll give you another architecture. You use it to model a complete structure to this point. All right. Apart from this one, after you've done this one fully, you do another one with the new architecture to produce this one, this kind of thing. Okay. Because you'll be using that one as your own project to for your self development. This is the one we are using in this class. That one you'll be using that one to practice for your engineering judgment to decide what best suits your project and all of those things. So that would literally not directly involve me, except you need some, and enlightenment or some clarity. Then okay, I'll come and do this, do that, do this. All right, but you take the most of the decision. With that, you can grow in your engineering decisions better and faster. All right, so that's what we're gonna do. Do you have any question?
Just, I was expecting corrections to be able to see the other.
You were expecting what?
I was expecting the correction under the one I made the they said I should do the other
Oh,
class.
yeah, yes, the one that you did. No basic correction. No basic correction. You know what you're gonna do for me, eh? Even on that, the AutoCAD file that you used. You did your GA on AutoCAD first, right?
Yes.
Now, convert it to PDF document and send to me so that I would highlight all those things for you. You can do that after this session. Convert that part, the plants after you have superimposed it. Superimpose your structural layout on your architectural layout for ground floor, for first floor, and for roof. Then send it to me. You get it?
Oh,
All right, so I'll be expecting that. Then you do this. Then I'll send you a new one. Okay, you have that. Okay, I'll send you one already so that you use that and practice too. So that and we'll move on from there. Okay, so that'll be all for tonight. Let's see if we can meet tomorrow again and pick it up from where we stopped tonight. Mm.